92 flights in 2025. China just poured $1 billion into Landspace's Zhuche-3 alone. The Long March 10A program is burning through government funding at a staggering pace. But Zhuche-3 crashed on landing. Long March 12A's recovery failed. Multiple boosters lost. Can copying SpaceX's playbook with unlimited cash actually work? Or is this ambition racing ahead of capability? Let's find out on today's episode of New Space Review. Landspace filed for an IPO on December 31, 2025, targeting $1 billion from Shanghai's star market. Every dollar is designated for one goal: scaling Zhuche-3 production and achieving booster recovery. This isn't just corporate fundraising. The star market recently relaxed entry requirements specifically for aerospace companies. Landspace, Space Pioneer, Galactic Energy are all queuing up. This is national industrial policy playing out through capital markets. But capital can't solve physics problems. Zhuche-3 proved that in brutal fashion. The debut flight looked solid through ascent and staging. Payload reached orbit perfectly. Then the landing burn started, and everything fell apart. The engine ignited but couldn't complete the sequence. The booster was lost. Landspace hasn't released details, but the failure mode is clear. The engine hit its limits after the ascent phase. Propellant leaks, turbopump issues, or thermal management failures, all common problems when pushing Methalox engines through multiple burns. Blue Origin just experienced similar issues with New Glenn's first landing attempt. Here's the difference. Blue Origin had years of operational experience with New Shepard before scaling to New Glenn. They understood reusable engine behavior fundamentally. Landspace is learning these lessons in real time on hardware costing hundreds of millions per unit. The second flight is now scheduled for the second quarter of 2026 at the earliest. That assumes successful root cause analysis, design fixes across the prototype fleet, and maintained investor confidence. The $1 billion won't last forever if they can't demonstrate recovery capability. Can Landspace move fast enough to justify the investment before their runway ends? While private companies chase reusability with market capital, China's national program is deploying government resources on an entirely different scale. Long March 10A represents this strategy perfectly. Derived from the lunar-focused Long March 10, the 10A variant targets low Earth orbit missions to Tiangong Space Station. Lower orbit means better performance margins, which enables recovery attempts. The design shifts are revealing. Drop the side boosters from the original 3-core configuration, reduce from 3 stages to 2, implement vertical landing. It's Falcon 9's architecture scaled to a 5-meter diameter. Projected performance: 14 tons to LEO reusable, 18 tons expendable. First launch scheduled for early 2026, but no firm date exists. No mission patch, no confirmed payload, no official timeline. For a program this significant, that silence indicates unresolved challenges. Then there's Long March 10B, designed for constellation deployment. Social media renderings show a Starship-like configuration: larger diameter, full reusability, integrated second stage. Target capability matches Guowang constellation requirements exactly: 11 tons to 900 kilometers at 50-degree inclination. These aren't incremental upgrades. These are fundamental architectural transformations happening simultaneously across multiple programs, all funded by state resources that likely rival NASA's Artemis budget. Which exposes the central problem with China's approach. China's aerospace strategy has always emphasized adaptation over innovation. Study foreign designs, reverse engineer systems, integrate proven concepts into domestic hardware. This works brilliantly for static technology, satellites, space stations, navigation systems. China has matched and sometimes exceeded American capabilities using this methodology. Reusable rockets don't work that way. They're not static hardware you can replicate from blueprints. They're dynamic systems where performance depends on thousands of operational decisions, iterative improvements, and institutional knowledge built through repeated failures. SpaceX didn't land boosters by copying designs. They crashed hardware into oceans and barges for years, analyzed every failure, modified their approach, and tried again. That process can't be shortcut. China is attempting to replicate the end result without going through the learning process that makes the end result possible. The evidence is already piling up. Long March 12A's recovery attempt failed in late 2025. Galactic Energy's Series 1 lost its upper stage and payload in November. Space Pioneer's Tianlong 3 escaped its test stand during a June 2024 static fire and still hasn't flown. These aren't random setbacks. These are systemic indicators that Chinese organizations are encountering the same fundamental challenges SpaceX overcame through iteration. Funding doesn't change that reality. SpaceX, 165 Falcon 9 flights, plus 5 Starship missions in 2025. Total, 170 launches from one company. China's entire aerospace sector, state enterprises, commercial startups, military programs combined, 92 launches. SpaceX alone launched nearly double what the entire Chinese space program achieved. But cadence is only part of the story. Falcon 9 booster landings are so routine, SpaceX doesn't highlight them anymore. Individual boosters have flown 20-plus times, total landings approaching 400. The system is operationally mature and economically proven. Meanwhile, SpaceX is mastering Starship recovery with Mechazilla tower catches. They've demonstrated super heavy captures. They're refining ship re-entry. They're building orbital refueling infrastructure. When Starship achieves full reusability in 2026, the gap won't widen. It'll become a different category entirely. 100-plus ton payloads to LEO, fully reusable, potentially multiple flights per day. No rocket in development anywhere matches that capability. China can invest billions and build impressive hardware, but they're chasing a target that keeps accelerating. When Landspace talks about Zhuqiang 3 recovery or Long March 10A promises Falcon 9-style reusability, they're competing against yesterday's SpaceX. By the time these Chinese systems reach maturity, SpaceX will have moved on to capabilities that make everything else obsolete. Does this mean China should quit? No. Competition drives innovation. Blue Origin's New Glenn, Rocket Lab's Neutron, Stoke Space's Nova, all push boundaries in different ways. But we need realism about where China stands. Investment doesn't guarantee success. Copying proven designs doesn't transfer institutional knowledge. Rushing programs before they're ready produces expensive public failures that waste resources and damage credibility. The question isn't whether China can eventually develop reusable rockets. They almost certainly will. The question is whether their timeline and approach can close the gap with SpaceX, or whether they're building yesterday's technology while their competitor defines tomorrow's capabilities. China has the funding, the engineering talent, and government commitment. What they lack is time, and the institutional knowledge built through years of iterative failure. SpaceX crashed boosters for over a decade, learning lessons you can't buy with billion-dollar IPOs or legislate through policy. Landspace's Jukie 3 will fly again. Long March 10A will launch. Some programs will succeed, but success isn't catching up, and catching up isn't surpassing. By the time China masters Falcon 9-style recovery, SpaceX will be operating fully reusable Starship fleets that make everything else obsolete. But 2026 is going to be incredible. Blue Origin's New Glenn pushing toward operational service. Rocket Lab's Neutron targeting first flight. Stoke Space's Nova demonstrating revolutionary technology. Add China's programs to this mix, and we're witnessing the most competitive era in launch vehicle history. The reusable rocket race isn't over, it's accelerating, and the gap between ambition and execution has never been clearer. What's your take? Can China close the gap, or are they building yesterday's technology while SpaceX defines tomorrow? Drop your thoughts in the comments. Want a deep dive comparing New Glenn, Neutron, Nova, and China's programs? Let me know below. Hit like if this analysis delivered value, share with anyone tracking the space industry, and subscribe to New Space Review for what comes next. 2026 is going to be wild.